Okay, so I'm going to solve problems number 5 and 6. Okay, so let's start with what is required. It says here what? Tension in the string. So all we're looking for is T. Okay? First, we have to make a diagram. It's an arrow as an arrow from a bow. So what does the bow look like? A bow looks like that, right? That's the bow. This is the string, right? It's like this. And the arrow is here, right? And then there's a force pulling this way, which is F. And that force is this one here, F. Okay? And that's actually given as 80 newtons. Okay, this is the given, and then I'm going to have to make a free body diagram. And look, we're also given the angle here is 25, and here 25. Okay? So, what does the free body diagram look like? F, which is 80 newtons. And then one of the strings is going like that, and its tension, of course, that's T1. And here, T2. Okay? And to the vertical, 25 degrees. Okay, I'm going to make it bigger so I can write the 25 here. 25, and here on the other side, 25. Okay? To the vertical. To the horizontal. Okay? So that's your free body diagram. You have three arrows, T1, T2, and T3. Okay? So what you're looking for is T1 and T2. A, T1, B, T2. Okay, now here is a question. Is T1 equal to T2? Well, you can't assume that right away, right? But what you can do is use summation of forces along the y is equal to 0. Then let's solve that. Summation of forces along the y, right, up and down, is equal to 0. And what is there's a component here, T1y and T2y, right? Look at that. T1y is equal to sine of 25 degrees times T1. And then T2y is T2 sine of 25 degrees. Okay? So here you write T1y is equal to T2y. Because this is the only up force, that's the only down force. This one is going to the side, right? So we replace that with this. You have T1 sine of 25 degrees is equal to T2 sine of 25 degrees. Okay, this cancels with that, and you'll end up with T1 is equal to T2, right? So these two are equal. You can write that down. That's one conclusion. Okay, that's your equation 1. And then you're going to make the summation of the forces along the x is equal to 0. And what is that? It's now this one. So T1x plus T2x is equal to F. Okay? Which is 80 newtons. Okay, so here we're going to write T1x is equal to T1 cosine of 25. Okay, because we've already used the sign. T2x is equal to T2 cosine of 25 degrees. Okay, so we substitute that here. Okay, what is that? T1 cosine 25 degrees plus T2 cosine of 25 degrees is equal to 80 newtons. Okay, these two are the same, so we're going to make that 2t cosine of 25 degrees. Why is that 2t? Because they're the same. So this t and that t are the same. It's just t, right? Is equal to 80 newtons. Okay, we're going to transform that. It's going to be t is equal to 80 newtons divided by 2 cosine of 25 degrees. Okay, cosine of 25 degrees, we'll move that to the bottom, right? And what is the answer? The answer is 95. So the T is equal to 95 newtons. Okay, so what you do is this becomes 40 divided by cosine of 25 is going to give you 90. Okay, so this is 95 newtons at 25 degrees. And this is going to be 95 newtons at negative 25 degrees. Okay? Because one is negative, the other one's positive. Oh, wait. Nope. Okay, it's 180 minus 25 is, sorry, 155 degrees and negative 155 degrees. Better. Okay? Check.